Hello students, in our previous lecture we have started the topic of the photoelectric effect. Till now we have learned all its three observations that we have concluded from the experiment, and now we are discussing the concept that the greater the energy possessed by the photon, greater will be the transfer of energy to the electron and greater is the kinetic energy of the ejected electron. Clear? You can see it here. If this light radiation will be of higher frequency and higher energy carrying photons are there, so then when they are going to collide at this metal surface, then a particular photon which will going to collide with any one electron will result in quick emission of the electron, and that photoelectron will also going to have a higher kinetic energy. Clear? In other words, kinetic energy of the ejected electron is proportional to the frequency of the electromagnetic radiation. Means more frequency, more kinetic energy we can see for this ejected electrons. Clear? So since the striking photon has energy equal to h nu, as you have already learned the expression for energy, that is E equals to h nu. Clear? This is the energy of this striking photons, and then the minimum energy required to eject the electron, that is h nu naught. Clear? For this rod, the value of the frequency is nu naught, not for this metal surface potassium metal we are using here. Then clear? So energy of the falling radiation is E equals to h into nu, and for this we can expect that energy for this potassium rod will be h into nu naught. Clear? So for incidenting radiation value is h into nu, and for rod this is for incidenting light. Clear? And for metallic rod energy is equals to h into nu naught. That is the second expression. Clear? So now you can see that then the difference in energy is transferred as the kinetic energy of the photoelectrons. Clear? Normally kinetic energy Ke is equals to half mv square. Clear? For here change in the kinetic energy we will going to get by subtracting both the frequency of the incidenting radiation and frequency of the energy of the incident radiation and energy of the rod that we are using. Clear? So from here you can see that kinetic energy is equals to h nu minus h nu naught. Expression for kinetic energy is half m v square, that is equals to h nu minus h nu naught. Clear? So as we have you can see from this expression that following the conservation of the energy principle, the kinetic energy of the ejected electron will be like that: half mv square equals to h nu minus h nu naught, or h nu is equal to h nu naught plus half mev square, where me is the mass of the electron and v is the velocity associated with the ejected electron. And lastly, a more intense beam of light consists of large number of photons, as we have already discussed that how much higher is the intensity of the beam of the light, more number of photons will be ejected, or more number of photon will going to strike on the metal surface, that will going to eject more number of electrons. Clear? So it is also larger as compared to that in an experiment in which a beam of weaker intensity of light is employed. Clear? So if we are using a beam of light having a weaker intensity, then the number of electron ejected will be lesser as compared to the more intense beam of light. So this is the photoelectric effect. Once read it by yourself and listen the explanation carefully. If any doubt is there, then you can clear your query anytime. Thank you.